So, good morning, everyone. I am Vishal Krishna Singh, and today I'll be talking about smart applications design, security, and threat analysis. And a special focus will be on smart cities and some of the one of the research problem which we have tackled using one of the techniques which involves a bit of machine learning, a bit of image processing, and everything for tackling this problem of which is quite popular in security surveillance systems. So, okay, allow me to turn off my video camera first. I think it might be causing a bit of disturbance. Okay, then. So, before I start my talk and enter into the details of various applications of IoT, and specifically in the context of this smart city, which I'll be talking about, I would briefly discuss some of the fundamental concepts which have been very popular and which have basically paved the path for this concept of smart cities as we know right now. So, uh, uh, this entire presentation is basically can be basically summarized under the following heads. After a brief introduction of all these building blocks of IoT and brief discussion about sensor networks, I will discuss the concept of the smart city. We shall see the general goals of a smart city and discuss the important differences between the sustainable model versus the smart models. Then moving to the next topic, we shall discuss the role the information and communication technology plays in the growth of the smart city concept and the various interventions or various impacts which this technology which has imposed or has facilitated in the growth of this smart city. Now, I've incorporated a brief case study which with the cities of Indore, Pune, and Jaipur. Now, these cities have already started working on the concept of smart cities and the cities Indore, Pune, and Jaipur. Now they have followed a specific model, and I'll not discuss the entire model in detail, but yes, they have their specific model which they are following, and it has been a catch. And different cities approaching these well planned cities. For instance, Indore has been doing really well, and we shall be discussing a bit about the model which they are planning and on which they are working. Similarly, for Pune also there is a smart traffic model which I'll be discussing in a bit detail. So now, I'll not discuss the models in detail, but we'll see the impact and the application areas where the concept of IoT has been successfully applied in these settings. Now, we'll also have a brief discussion about a research problem. As I said, the research area over here is a brief research problem, which has been an important concern in the security and surveillance applications of smart devices, and not only smart devices but in smart cities as well, which is the problem of accurate event detection. Now, shall we when we reach this topic, then I shall discuss this research problem in detail and the problem and the solution which we have proposed. But yes, so accurate event detection in surveillance system is basically what we'll be discussing as a research problem, and then I'll describe the problem in a bit detail, and then quickly I'll try to explain the solution which we have given for this and the results which we have obtained with the proposed solution. And finally, the concluding comments, right? So. Uh, I hope all the members who are present over here have a basic idea of what wireless sensor networks are and what Internet of Things are, and because without these are basically the fundamentals or the building blocks of any smart city or any smart city model when we are talking about. So before starting the smart city and the goals of a smart city or the important concepts of a smart city, I'll quickly go through the concepts of wireless sensor networks. I'm hoping that most of you are aware of the concept of wireless sensor network, and for those who are not, I shall briefly go through the building blocks of this IoT and the smart city network. So when we talk about wireless sensor networks, it is basically a ad hoc distribution of sensors. Now, ad hoc distribution of sensors, that means that the sensor nodes are deployed in the area, and these sensor nodes cooperate with each other. And cooperate in each other, that means they try to communicate with each other. They formulate a transmission path. They formulate a communication path so that they can sense and transmit the data from the place or from the point at which the event is detected to the processing center. Now these sensors cooperate with each other to report any physical phenomena that might be a temperature, a sudden temperature increase, a fire, gas leak, motion, or there are so many different kinds of sensors we see in our day-to-day life, and all these sensors or all these devices, when placed in such a way that they cooperate with each other in the process of sensing and transmitting the data, so that this data can be processed at a centralized unit or a base station, we say. This information, when it is used in this fashion, they together form a network of sensors, and hence the name wireless sensor networks. Now, this information which is being generated by these sensors is a significant amount, right? So, as no, the concept of wireless sensor networks is not a very new concept, and it has been in the research and in the application domains for so many years. But when you see that the amount of data which is being generated, the amount of data which every sensor network, every sensor node, every node in the network generates, that is quite a thing, right? Now, the every sensor node, when I say every sensor node, that means a single sensor node generates sufficient amount of data that can be classified, that can be difficult for a small node to process, right? So these sensor nodes are not capable enough to process this huge amount of computation, or to process this huge amount of data, or to execute complex computation. So what happens is, this data is transmitted to a base station, or to a sync, or to a much more capable device or machine, where this entire data is processed. Now you see, when a single node starts transmitting this data, it is not always the case that the sync will be in the communication range of this sensor node. So what happens is, they formulate different they try to transmit the data using different routing protocols. They might be connected in a tree network, or they might be using a clustering scheme for transmitting the data. But the idea is that the data, once sensed by the sensor, is transmitted to the base station, where it is processed. Now, processing means the amount of data which is being received at the sink, it is from so many nodes in the network. So the amount of data is huge, and what we have to do is, I'm saying. So at the sink, what we have to do is, we have to process this huge amount of data, and we have to infer some decision. We have to come out with a decision, or we have to analyze this data and make a useful interpretation from this huge amount of data. Now, this is the general idea of a sensor network. So if you look at the applications of sensor network, there are so many. They can be used in environmental monitoring. They can be used in military uses. They have They have day-to-day uses, and there are so many applications of wireless sensor networks. Uh, yes.
Yeah.
Sir, I'll mute them. Actually, one participant has turned on his mic.
Yeah.
Okay.
Unmute also I am okay.
Okay. Okay. So I'll continue then. So
Chandranagar Miyapur.
Sir, you can proceed. I have
okay.
muted.
So so as I said, the applications of wireless sensor networks are huge. Not only in surveillance systems, not only in environmental monitoring, not only in these various traffic monitoring, not only in smart city, not only in industry. You can find the applications of wireless sensor networks in almost each and every application which we are currently seeing, using, or which we might have interacted with. Now, in all these applications, one thing is very common, and that is probably the basic nature of the sensor network, that the amount of data being generated is huge, right? So this huge amount of data requires processing, and as I said, these networks are deployed and are not capable of processing this huge amount of data. And why is it that? Because there are so many factors involved, right? Because see, the sensor nowadays the sensor nodes which are being produced and which are being developed in the market, they are much more efficient and much more capable. But then again, they are battery powered. Now, in a battery powered sensor network, you see in a battery powered sensor node, you see that the energy or the battery is limited, and hence the entire objective, or the in most of the cases, in almost all the cases of applications of wireless sensor networks, you will deal with the problem, or you have to address the issue of lifetime maximization. Now, lifetime maximization is an important concept, because as long as the nodes are alive, they will be sensing and reporting. So as soon as the first node dies, the threshold period, or the stability period, I would say, the stability period is that is the length of that is the duration of the stability period, or that is the stability period till the time when the first node dies. So the entire objective in most of the applications, or almost in all of the applications, is lifetime maximization. And the in order to achieve this lifetime maximization, it is often approached with the idea of load distribution. So evenly distributed load results in an improved lifetime. That is quite a straightforward deduction, that if the load is evenly distributed throughout the network, then it can be helpful in maximizing the lifetime. Although there are so many other factors involved, but yes, if I have to say in a single statement, or in a very general term, then I would say that the load distribution would definitely affect the will definitely positively affect the network lifetime, right? If we have even load distribution, the lifetime of the network would definitely improve. This is a general statement. There might be a few of the cases in which this might not be true, but I hardly can think of any of such a area. So, having said this, having discussed the bits and pieces of the wireless sensor networks, let us quickly move to what IoT network is. This, and then we can move to the smart city concept. But uh, when I say IoT network, now, IoT network basically is nothing but it is, as the name indicates, it is the Internet of Things. Now, as I said, that the name describes what we are talking about. Internet of Things. That means a network of physical objects, which are physical objects. Now, these objects are considered as things over here, and this we say that the this IoT describes a network of physical objects. Now, these objects are embedded with sensors and softwares and such technologies, so that they can connect with each other, they can exchange data with each other, they can interact with each other. And how do they do this? They do this over the internet. So the idea is very simple, that a set of devices or set of physical objects. Now, in this context, they are known as things. Now, a set of things, they are which are capable of sensing, processing, computing, and everything. They connect with each other. They exchange data with each other. They can make valuable deductions on their own, and they have computing capability, they have processing capability, they have the ability to make inference on their own. Now, so these devices when connected with each other in such a way that they can exchange data with each other over the internet, then such a network finally is known as internet of things. So these devices connected over the internet in such a way that they can exchange data with each other are called IoT. Now, if you are looking for examples of IoT, you might have seen so many examples. Maybe you might not have categorized them as an IoT device, but yes, you can see so many IoT devices in your surroundings right now, because you can see a YouTube video or on Facebook or on these social media platforms. There are so many things where
మధ్యలో పెట్టమని అడుగుతుంది.
these IoT devices are applied. Now, we have seen the example of smart LEDs, right? A light bulb. We have seen the light bulbs which can be switched with the help of a smartphone. We have seen refrigerators. We have seen air conditioning systems. We have seen music systems. We have seen smart cars. We have seen smart mirrors. We have seen different applications of smart homes, which are fully accessible via a smartphone, right? I hope all of you have witnessed one or the other thing in your day-to-day life. So the idea of IoT is quite simple. Once we have clarified the idea of what are the wireless sensor networks and what is an IoT network, then and see all these wireless sensor networks, and why I'm discussing wireless sensor networks and IoT instead of discussing the smart city, because the sensor networks were the foundations on which the IoT network was built, and the IoT networks have one of the applications of IoT network is a smart city. So it is quite fundamental to discuss these two things, because without having a proper knowledge of these two concepts, the concept of smart city might not be very useful, or might not be very clear by the time this session ends. So once I have discussed this wireless sensor networks and what IoT is, now this is a very genuine question which might pop up in your mind, that why to use IoT now? What is the advantage of using IoT now? What is the benefit of using IoT now? Because since IoT is not a very recent concept or very new concept, although it from the past 15 to 20 years, we have been hearing things about such technologies which can help us in detecting these things, which can help us connect with the smartphones, right? So why IoT is becoming all of a sudden, this concept of IoT, this concept of smart city, smart mirrors, smart city, smart traffic, smart transportation, everything we hear now is basically related to all these things, and why this concept has become suddenly popular. And the answer to that specific question lies in the basic growth of the technologies, or in the basic in the fact that the technologies which we have seen in the recent 5 or 10 years, they have they have had a phenomenal impact on these technologies, because IoT is not just a sensor node and a communication and the internet, right? So there are so many things involved, and to answer this basic question, that why IoT should be used now, or why it is becoming popular all of a sudden, we have to acknowledge that that IoT, as far as IoT is considered, it has been in existence for a long time, but recent advances, when I'm talking about a collect, not only one advance in a specific field, or one of the important aspect in a one major development in a specific field. I'm talking about recent advances in a number of fields, in different technologies, in different domains. Now, since all these technologies have been growing in a tremendous way, and a collection of all these advances in different domains, in different technologies, have made it possible for the IoT applications to address to become more and more popular in the current scenario. Now, if you're looking for examples on this statement, you can simply see that, for instance, when we talk about the access to the low cost and the low power sensor technology. So as I said, the sensors which we have seen in the which were available in the market in 10 years back, are now much more cheaper, much more efficient, much more affordable, and much more reliable. So this low cost sensor technology and low power consumption sensor technology has been a primary driving factor in popularizing the idea of IoT in the current scenario. Now, these sensors are, as I said, now they are more reliable, more affordable. So many applications of IoT are becoming more and more popular, and becoming more and more. We are seeing more and more applications of IoT devices in the current scenario. Now, if you see, if you look for other facts to highlight this fact, then it goes without saying that the connectivity of these devices, by connectivity of these devices, I mean to say that the protocols which allow the connection of these devices or these sensors to the internet have been are much more optimized, are much more easier to implement, and much more easy. They provide much easier connectivity to the sensors to the cloud, which makes the data transmission fairly much more which makes the data transfer much more relaxed. Now, to apart from these two, you can see that the concepts of machine learning and artificial intelligence, they are also being utilized in our in the concept of wireless sensor networks in IoT on a daily basis, maybe more. So. Considering the amount of data which was being generated, as I was initially stating, that the data which is being generated in a sensor network, or similarly in an IoT network, is huge. And so use of data analytics techniques, or use of machine learning techniques, or the need of processing this data and the need of analyzing this data is becoming, and the time frame involved, like we are supposed to process this data immediately and respond with the correct output or correct inference as soon as possible. So the amount of data processing involved, the amount of data analysis involved, and for the huge amount of data involved, the machine learning approaches have been the one of the most important and one of the most influencing and one of the biggest contributor to the spread of this IoT technology. And similarly, you have seen the use of natural language processings, use of AI techniques in IoT. You have seen the example of smart personal assistants such as this Siri or Alexa and all these things. So you see that these technologies have made IoT householding. They have made it possible, made the IoT technology possible to enter in our day-to-day life, and in such a affordable manner that this technology is becoming more and more popular, and there are different aspects in which this can contribute to the society. Now, in out of the many applications of this IoT technology, when we implement this IoT technology in an industrial domain, now industrial domain, that does not necessarily mean that it is a textile industry or a coal industry or a automobile industry. It can be anything. When we implement this IoT technology, when we are talking about the applications of IoT technology in industrial applications, in any of the industrial applications, this technology is named as industrial IoT. Now, the industrial IoT, the work in the industrial IoT has been phenomenal and has served many purposes, such as this smart city is also one of the many aspects of industrial IoT. But to remaining on the topic, what industrial IoT is basically it is the machine-to-machine communications, which this in case of industrial IoT, what we basically aim for a machine-to-machine communication with technologies such as cloud, machine learning, IoT, AI, and all these things when combined together, they are part of the industrial IoT, and they can provide a number of research fields, these ideas for research fields and research ideas and innovation ideas, not only for researchers but also for many innovators and entrepreneurs and everyone. So among the many common uses of industrial IoT, now few are the smart manufacturing, smart power grids, smart supply chains, and the one which we are going to talk about is the smart city. It is also one of the many applications of industrial IoT, and as I said, we shall be discussing this in detail. Now, in the upcoming hour, I'll be discussing the basic features of smart cities, and will address one of the fundamental security applications in such environment. Now, this application in a security, this application which I'm talking about in the concept of smart city is basically a surveillance system, and how IoT or how these or wireless sensor networks and the related technologies are capable of are used for surveillance, and what are the research problems in this domain. And what is the exact problem? The exact problem, as I said, is the detection of events, right? Because in surveillance systems, we are basically looking for an event which might take place. So we are basically looking for the accurate detection of events with the idea of minimal human intervention. But we'll come to that, but for now, as we can see, now coming back to the topic at hand, that is the smart city, then I will say that as we can see around ourselves, that the world is rapidly urbanizing, right? There on a daily basis, people are moving from villages to cities, and from cities to metro cities, and in the search of job, education, and for so many reasons. Now, this tremendous speed has resulted in what? in this a tremendous growth in the population of the from villages. People have moved to towns, from towns to cities, cities to metro cities, and then this cycle goes on. Now these most cities which we are talking, they started, they were basically small centers, but now they are accommodating a far greater number of people than they were originally planned to, or that they were intended to. Now, such as rapid growth in this population is adversely affecting the building blocks of this city infrastructure. Now, these city infrastructures, when I say, it means that the roads, the bridges, the communication system, the traffic system, and all those things are getting adversely affected. Now, these systems, these roads, traffic systems, the transportation systems, the traffic management systems, and all these things are already working on in their full capacity, and they are running 24/7, right? Now, to cater the needs of all this tremendously increased population, what do we need? We need some. We need to incorporate the use. We incorporate the current information and communication technologies to streamline the process, to improve the quality of living in such urban world. Now, in order to do this, in order to provide the basic necessities, such as, now I'm talking about basic necessities, because you see, as the population grows, the basic necessities are what we are targeting with the in this smart city concept, because these are when you realize that the sudden increase in the population of the cities has resulted in lack of these basic facilities. So, in order to provide these basic necessities, such as the clean water or clean surroundings or clean habitat, without imposing any extra overhead on the nature. And by nature, I mean that the foot or the impact which we might have on the nature because of this, because of the technologies which we are incorporating in this environment. So, without imposing any extra overhead, without imposing any extra overhead on the natural state of the things. This is what is a smart city is all about. So the idea is to use information and communication technologies in such a way that these basic necessities can be provided to the citizens of the city or citizens of the of that specific domain which we are referring to. So, considering this in mind, the definition of a smart city can be seen on the slide over here, as a smart city connects human capital, social capital, and information and communication technology infrastructure in order to address the public issues, achieve a sustainable development, and increase the quality of life of its citizens. So, it is basically what I said, that provide the basic necessities such as anything: clean water, clean surroundings, clean habitat, with the help of the information and communication technology. Using, incorporating these technologies in our day-to-day life, we can definitely improve the quality of life in these cities. Now, to understand it clearly, to understand the definition clearly, it is basically what I'm trying to say is utilizing the scalable solutions of, now when I say scalable solution, I mean to say that all the solutions which involve information and communication technology to remove, or it would be better to say, to minimize the issue of the urban world, or the of the cities in a, no issues. When I say issue, it means the basic facilities, such as the I'm talking about 2 or 3 basic facilities: clean water, clean surroundings, clean habitat, basically, let us say I'm talking about these three things. There are so many more things, but basically, in order to understand this, you need to address. I'm addressing these three only. So, using the information and communication technology to remove or to minimize the issues of these basic necessities in a cost-effective manner, in a reliable manner, and in an efficient manner, so that the quality of life for these for the citizens of the city, of the state, of the country can be improved. Now, these goals of the smart city, as I just explained, can be very much derived from over here, and that is smart city goals. As you can see over here, it is achieve a sustainable development. Now, sustainable development, I hope all of you have a basic understanding of what sustainable development is. So, one of the, as I just said, as I just explained from the definition of the smart city, that what is the fundamental definition of smart city. So basically, it is achieving a sustainable development. Now, increasing the quality of life of its citizen. That is that is also quite obvious, and that has been much discussed in this definition as well. Also, improve the efficiency of the existing and new infrastructure. So, whatever infrastructure, whatever resources, whatever we have at the present, that can be improved, and that can be and whatever new technology or whatever new resources which we are developing, that has to be used efficiently. Now, to achieve these goals, and as I said, the information and communication technology factor, this plays an important role in the concept of a smart city. So, as I said, to achieve these goals over here, and by utilizing the information and communication technology, the traditional sustainable model can be easily modified to a smart development model. I hope you can see the figure over here. This is the sustainable development model which we have seen in various applications which we might have seen, in various studies which we might have seen. But in a smart city environment, or in a smart development model, we need to incorporate we need to incorporate some of the factors which are important for improving the life quality, or for improving the quality of life in such a smart city, or in such a smart environment. Now, these three factors which have been introduced, which have been introduced to make this model, or transform this model from a smart development model to from a sustainable development model to a smart development model, are these three factors which you can see over here. Is the first one being the technological factors, the second one being the human factors, and finally the institutional factors. Now, to understand these factors, we need to understand the basic concepts of a smart city. That the smart city is basically governed by a smart governance, smart economy, smart mobility, smart environment, smart people, and a smart living. Now, in order to understand these factors which I am talking about over here, are basically as you can see over here, they are the enablers of the smart city. Now, when we talk about smart governance, as soon as I say smart governance, then you can see in the figure on the screen over here is which shows that smart governance means IT connectivity, online citizen services, and various governance related issues which can be made available to the citizens of the city through internet. Then, as I said, the other factor is a smart economy. So many employment opportunities can be popularized, can be made available to the citizens in the online through the online and through the smart mediums. Smart environment. When I say smart environment, we have already witnessed the role of a smart environment, and we are already in one or the other way contributing to this. We are seeing on a daily basis renewable sources of energy, green buildings, pollution control mechanisms, and all those things. As far as smart mobility is considered, transport, traffic, walkability, all these issues are addressed under the smart mobility. Smart transport and smart traffic has become very popular and are implemented in so many cities. Now, smart people. Now, this is probably the most important concept which you'll see, because you'll say what is the concept. Okay, I'll discuss smart people in the last. So then there is smart living. That is smart housing, smart water supply, smart electricity, smart public open spaces, sewage systems, sanitation systems, and all these things, if they can be managed in a organized way, or in a way in which they can use this information and communication technology, so that they would not impose any extra overhead, and that would streamline the entire process. This contributes to the smart living environment. And finally, the smart people, you would say, what is the need of smart people? What do you understand by smart people in the concept of a smart city? You see, all these things, the smart living, smart governance, smart economy, smart environment, smart mobility, everything is of no use if the people who are availing these facilities, who are making use of these facilities, are not aware of the advantages of these, are not using the resources to the so that they can benefit most of the people. So education is important, and to allow education in such a way that it reaches the masses, it reaches most of the people who are the citizen of the country, of the state, or the city, or whatever you can call this. But to make this education available to the masses is what smart people, what contributes to the smart people. Then again, smart health, or the health factors which is imposed in this, is because of this is just a minute. Okay. So smart health, or the health factors which is imposed in this, is because there are so many health applications which are popular. And if we can use information and communication technology and these technologies which we were discussing just now to improve the life, we are talking about improving the lifestyle of the system, or lifestyle, or the quality of life of the people, then smart health has to be introduced. So education and health are probably the driving factors, and then there comes the entertainment and cultural activities that do also play an important role. So all these factors combined together contribute to the smart city environment, and they, in one or the other way, they are responsible for the development or the success of a smart city. Again, I would say the people, or the citizens, or the people who are involved in using these resources, the resources you can develop. You can develop a smart transportation model, but the people who are using those resources are, you have to make necessary arrangements for educating them, for making them aware of the advantages of this technology. So as I said, and if I say that these are the basically, this figure over here shows the chart over here. This chart you can see on the screen, and this table is basically describing the impact and the contributors and the action areas of the smart city, which becomes which we are using, or which can be addressed in a smart city environment. Now, as I said, that we'll be talking about the case studies of these different cities or different models. So I'll not discuss the entire case study, or not the entire model which these cities are following, but one of the most important factors which these cities, or all the what I have found common in all these models, which the cities of Indore, Pune, Jaipur, Bhubaneswar, Bhopal, all they have, what they have done is they have they they have laid a great emphasis on citizens' feedback. Right, they have taken feedbacks from the users. They have addressed the issues. They have addressed the grievances. They have tried to obtain the solutions for the grievances for the queries resolved raised by the citizens of these cities, and they have made them aware. They have made them aware of the advantages of these technologies. They have made aware of the resources which will become available to them because of this technology, so that they can improve the standard of living. They can use these resources in a much efficient way, and they can get maximum benefit out of this. Now, as I said, in case of you can see on the screen that in case of Indore, continuous citizen consultation, feedback, education programs, and all these things were conducted by social media platforms such as Facebook, Twitter, and all these things. There were physical interaction, there were awareness programs, and similar efforts were imposed over there. Now, similarly, these are some of the applications of some of the probably the highlighted projects which are being developed in Indore after making use of the IoT technology, or the making the realizing the dream of a smart city with the help of IoT. These are two of the most important projects which are being implemented in the city of Indore. In the city of Pune, we can see the issue. This is a very common problem, and this has been addressed in many cities, and many people are working on this smart transportation and smart water system. Now you can see the smart transportation system. It is quite popular in Pune, and it is working. This model has been adopted in Pune, and you can see again over here, they followed this model. They took the feedback from the customers. Now this the idea of a smart transport and a smart water. Again, it comes back to the citizen awareness and the sensible use of the resources. Now the technologies, as you can see, they can be implemented now. As it is seen in the as you can see in the model, these technologies can be implemented. Now the various technologies which the smart transportation have involved is, first of all, you can see the vehicle health movement. Now the vehicle health monitoring. Now, the vehicle health monitoring, this system incorporates and reflects the health of the motor car or the bus or the transportation vehicle which is being used. So it reflects the health of the entire system, the battery percentage, the condition of the braking system, the mobile and everything. All the mechanisms involved in the machine can be reflected on this monitoring system, and it is displayed on the screen, and the driver or the system administrator can easily check the status of the vehicle, if it is fit to use or not. Then again, the passenger information system, you might have seen this in one or the other city where this has been incorporated. The status of the upcoming transport, which might be a bus or a metro, or you have seen that the status of the metro train is visible on the screen. So this passenger information system is visible with the help of vehicle tracking. They track the vehicle at exactly where it is, and how much time would it take to reach the designated system. Now, how to do this? Now, again, there are intelligent road and asset management. Now, intelligent road and management systems can be asset management system can be so many. For instance, the smart traffic system, or this smart traffic system that allows to generate a heat map of the traffic in a specific area, and accordingly the traffic lights are switched on, are shuffled from red, green, and yellow according to the traffic. And similarly, the divergence can be created in advance, depending upon the peak hours of the traffic in a specific area. So the heat map and the intelligent road asset management can help in that. Then again, smart parking and multi-level parking, safety features, all these are part of the uh, smart public transport, which has been implemented which is being implemented in many cities. I have taken the example of Pune. Again, in the case study of Jaipur, they have already started working on taking the feedback from customers. Again, as I said, I would say customers, because it is ultimately the end users who are involved over here are the general public, which is going to use all these resources, who are going to use these smart transport or a smart water management system, or a smart waste management system. All these address all these issues will be or all these technologies will be used by all these technologies will be used by okay, just a minute. Okay, all these technologies will be used by the end users, and basically uh, hearing. Okay. Okay. So they have already started taking feedback from the people. They are already collecting the requirements of these systems. The idea behind developing a city into a smart city is basically the addressing all the issues and grievances of the end users. And end users in this is the general public. Now, as far as this is considered, that this is okay. Now, again, as far as this technology is considered, this there are so many tech. As I said, the smart transportation can be of so many things. Smart asset management, smart traffic systems, smart heat map generations, and traffic control systems, traffic monitoring systems, smart parking, smart parking systems. All these in total provide a smart transportation system, vehicle monitoring system, vehicle health monitoring systems, vehicle tracking systems. All these are part of a smart transportation system, and they are, although they are small components, but then again they together come as a whole as a smart transport system, and they cannot be used to its fullest unless the end users who are incorporating or who are discussing this or using this pay the required attention. Now, as I was saying, the finally the safety and security issues which are in the smart saying, because considering the limited time which I have, I'll quickly move to the problem which I was about to discuss, is the detection of important events. Now you see that if you closely monitor the entire scenario of threat analysis and which makes the detection threat analysis in a smart city or in surveillance system, you realize that detection of events is the most important. It's probably the most important thing which you'll see. The most important task is in such a system is the accurate detection of events. And thus the research problem which I am addressing over here is the detection of important events. Now, when I say important events, it is basically considering the example of a surveillance system, you can think of that in a surveillance system, there are so many people moving in and out of the video frame, right? And all of these people can be considered and considered as an event, right? So all these people can be considered as an event, but we are not interested in addressing each and every. We are not concerned about addressing each and every movement of a specific person, because in a surveillance system, what happens is there are so many events happening simultaneously. If the movement of a person, or if a person passes through through the video camera or through the frame, if that is considered as an event, the surveillance system would fail, because there are so many people passing in a crowded space. So many people are passing through that system at a simultaneously, that it is not feasible to monitor each and every person simultaneously. What happens is, we have to look for events, for instance, a specific movement, for a specific threat. Now consider a event which has now been identified as a event of importance, right? EOI, as I say, the event of importance. So if a EOI has been identified, this problem uh, starts at this point. Now, once the EOI has been identified, the problem is that these EOIs, what happens if a system fails, or what happens if the sensor node fails, or what happens if the surveillance or the whatever is the device through which you are monitoring the system fails. Is it the case that the data, whatever it was reporting, will be lost in the system, or even if the partial data is reported, the system will not take any use of that? Or basically, if there is an anomaly in the system, basically if there is a glitch in the system, then all the normally reported events are considered, they are appropriate actions are taken, that is good, that is perfectly fine. But what about the anomalies? So as I said, detection of important events, or detection of events of importance, or detection of EOIs, or detection of anomalies. So I'm referring to these important events as anomalies. Now, how do I define an anomaly in this scenario? Is that I'm considering I'm considering the idea of persistence period. Now, say event is generated, and this event takes place, and we have to assume that the persistence period of this event is, let us say 5 minutes, right? So once the event has started, it will continue for 5 minutes. I'm not saying that 5 minutes is the ideal scenario, but just for the sake of understanding this entire concept, consider this, that once an event has started, let us say a fire has started, and a surveillance system is placed over there, and then I say that once the fire has started, the sensors placed in the proximity of that event will start reporting it. Now these sensors will report the event, that is fine, but what is the minimum duration for which this event will continue? So this is what the persistence period is. So the persistence period can be defined as the minimum duration for which the event is considered to be valid. Now let us say I say that if a fire is started, it will continue for the next 5 minutes. So once it is started, for the next 5 minutes, the sensor or the node which is deployed in its proximity, it must report that there is a fire in this area, right? So once I say this, that the persistence period has to be ensured. That can be 5 minutes, that can be 10 minutes, that can be 2 seconds, that can be 3 milliseconds, whatever that unit is, but that persistence period has to be ensured. Having said this, that the persistence period has to be ensured, it is quite possible that the node what will be the case of an anomaly? The anomaly will be that, let us say the event is being reported for in 5 frames, right? Let us say the first frame, second frame, third frame, and fourth frame, and fifth frame. Now the event was reported, the persistence period is of 5 frames, right? However, the event was reported in the first frame, in the second frame, in the third frame, but not in the fourth and fifth frame. So if this happens, what will happen is the event will be, let us say if event occurs, it will be reported as 1, and if it is not, it will be reported as 0. So what happens, what the data which you will get at the processing center or at your base station would be something like, for the first frame, you will get 1. For the second frame, you will get 1. Then again, for the third frame, you will get 1. You get 0. For the fifth frame, 0. Now, what is this? This is not a normal behavior of such an event, because we already know that the persistence period is of 5 frames. So there must be some fault at the reporting side, or at the receiving side, or from the sensor nodes, or from the devices which are deployed in the area. They are not able to report the event properly. Because of this, what happens is, this is considered as an anomaly. What if this might be of significant importance, but because it is not reported for the persistence period, for the entire duration of the persistence period, this will be considered as an anomaly, and it will be discarded. But no, it will not be discarded. This problem of anomaly detection, or detection of important events, was considered by us, and a model was proposed for scheduling the nodes in such a way that, if the events are detected in this persistence period was defined, the EOI was defined, the detection, the awake cycle, the duration of time slot, everything was defined. And what happened was that we identified this pattern. We employed a technique for identifying this pattern of detection of events. As I said, 1 1 if the events are reported correctly, 1 1 or 0 0. But it cannot be the case that 1 0 or 0 1 is not a valid response. Because if 1 0 is there, then for the entire duration, this must be 1 1 or 0 0. The event either happens or it does not. So in all these cases, we need to awake, or we need to deploy more number of nodes. Not deploy, we need to awake more number of nodes in that specific area, because this node which is generating a faulty data, the data coming from this node has to be verified, and for that, spatially correlated observations, or spatially correlated data was obtained by activating more number of nodes in the area. Now, what happens is, activating more number of nodes in the area results in increased traffic, reduced lifetime, and probably some congestion in the network. So, considering all this, there is this technique. There is this method of compressive sensing, which has been very popular in the field of image processing, and it incorporates data compression in such a way that it ensures that, instead of collecting all the samples of the data, if the data can be represented in a sparse domain, the data can, instead of collecting all the samples of the data, only few weighted samples of the data can be collected, and only few weighted samples of the data contains most of the information. Now, from these most of the from these weighted samples, the original data can be reconstructed. So instead, when we awake more number of when we activate more number of nodes to get the spatially correlated data, we transmit the information by the relatively large number of nodes. Then this information is communicated by using the compressive sensing method. This allows not only reduced transmission, but evenly distributed load. So this helped us achieve not only improved lifetime, not only accurate detection, but also improved load distribution. Now, this paper was published by us in 2018 in IEEE System Journal. So some of the evaluation matrices which we used was accuracy rate of true positive, false alarm rate, area under coverage. Now these are all very common matrices which are used for evaluating the accuracy of the system or the performance of the system. So I'm not going into the formula in detail, but we tested the proposed system on a freely available data set, and we also conducted our own experiments. So the results of the proposed scheme, the method which I showed over here, okay, just a minute. The algorithm over here was implemented on some of the was implemented and tested on the freely available data set, and we obtained a fairly improved performance in terms of not only accuracy rate, in the rate of true positive, in the false alarm rate, and in the area of coverage also. And we also performed the simulations in MATLAB, and the nodes were randomly created. And as you can see, the heat map which is being shown over here is reflecting the load distribution of the network. This is the entire network in which the nodes were deployed. The events were detected, and in case of an anomaly, or in case of EOI, what happens is, this is the probability of EOI is 0.2 in this, probability of EOI is 0.6, and probability of EOI is 1. And in all these scenarios, you can see that the load distribution or the spatially correlated data is being transmitted by the nodes using the compressive sensing method. Now, this compressive sensing method results in equal load distribution, and hence you can see that most of the areas in the network are colored in bright yellow, which is mostly this number over here. It is basically the number of transmissions in the network. So most of the area in the network is yellow, which shows that the entire network is more or less having the same number of transmissions. Then again, the lifetime analysis was conducted, and as you can see that the lifetime of the proposed scheme is much better as compared to all the other schemes compared over here. But what other important thing is that you see that not only this scheme was able to outperform the MNNIT and SVM based methods, but also, okay, I will not discuss these three methods in detail, but yes, I'll say that the proposed scheme performed much better as compared to the existing schemes. Now, this is the result which is of importance over here, which is and why is it important? Because we started with the accurate event detection, and as you can see, is the accuracy rate or the range of the accuracy in this case is very high. The accuracy rate is very high, and the false alarm rate is very low. And this is primarily the objective of the entire method, that the events or the anomalies or the events of importance which we are addressing, or which we are trying to detect, they must be detected with accuracy. So the data for an anomaly must be reported correctly. With the help of spatially correlated data, we were able to obtain improved of the accuracy and false alarm rate. Now, the runtime comparison was also conducted, and we were able to get a fair advantage over the existing methods as well. So, in order to finally to summarize this entire discussion, I would say that there are three things which a smart city or a smart development or smart ecosystem is we should be hoping to develop. That is, there are the 3 R's, which is reduce, reuse, and recycle. Now, if we are able to optimize our resources, our technology, our existing methods in such a way that they are able to provide better solutions for these problems which are which we experience in our day-to-day life because of such things. For instance, the smart transport. It is a very common problem which we all see in our city, in our town. Similarly, the waste disposal mechanisms, these sewage treatment plants, and all these things are day-to-day problems, and smart solutions can be developed for all of them. And if we can somehow optimize the methods. The methods are available with us, but just to implement them in a proper context and in such a way that they can be optimized in such a way that they can improve the performance of these systems is what we are looking for in smart cities and implement and making use of the IoT technologies. So that will be all for from my